Space, the final frontier. This is the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Its mission to explore the solar system, to seek out new observations and data, to boldly go where no podcast has gone before. And now the host of the Observer's Notebook, Tim Robertson.
Hello and welcome to episode 195 of the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. I'm Tim Robertson, the host of the Observer's Notebook and also the coordinator of the training program within the ALPO. Thank you for downloading and listening. The Association of Lunar and Planetary Observers collects and analyzes observations of various solar system bodies and associated phenomenon, and publishes detailed reports concerning these bodies in its quarterly publication, the Journal of the Association of Lunar and Planetary Observers. This podcast depends upon donations from you, our listeners. Keep it going. If you enjoy what you hear in the podcast, you can donate to it via Patreon by giving as little as $1 a month. If you feel even more generous, for $5, you receive early access to the podcast before it goes public. For a monthly donation, you receive a copy of the Novice Observer's Handbook. And for $35 a month, you receive producer credits on the podcast. You can help us out by going to www.patreon.com/observersnotebook. If you'd like to join the ALPO, membership begins at only $22 a year. For more information, find us at www.alpo-astronomy.org. And you can also find the ALPO on Facebook. Just search for ALPO Astronomy. And yes, the Observer's Notebook also has a Facebook page as well. Just search for Observer's Notebook. And if you enjoy what you hear in the podcast, please subscribe. That way you'll never miss another episode. Now, episode 195 with ALPO coordinator Richard Schumde, and we're talking the planet Uranus. Enjoy. All right, I'd like to welcome everybody back to this edition of the Observer's Notebook podcast. And today we have the coordinator of the Remote Planet section, Richard Schumde. Welcome to the podcast, Richard.
Thank you, Tim.
Now, before we get started, why don't you just give everybody a little bit of background about yourself?
Okay, I'm a professor at Gordon State College, just south of Atlanta, Georgia. And I've been observing Uranus and Neptune since the late 1980s, and I started out just observing with a telescope, and quickly I started taking brightness measurements of Uranus and Neptune. This is one area where I felt as though I could make a contribution using an SSP3 photometer.
Oh my. That dates you.
That dates me, yes, but I've still got an SSP3 photometer, and I wanted to get some measurements of Jupiter and Mars this morning, but I just looked in the sky and there was some clouds creeping in, so I just scratched that one.
Yeah, is a hurricane anywhere near you guys?
I don't think so. The forecast this week calls for a mix of sunshine and rain.
Oh, good.
More of the latter, though. More rain.
All right. So, what brought you to the Association of Lunar Planetary Observers?
It was back in 1981, and I was reading an article in Sky and Telescope magazine. I believe it was by Jeff Bish, who's still on the he runs the Mars Cafe now, so he's still around. Mm-hmm. And him and Don Parker were quite the pair. They did a lot of great Mars work and analysis.
They were quite the pair.
They were, and of course, Jeff is still with us. Unfortunately, Don Parker passed away a few years ago.
Right. So, what event sparked your interest in astronomy to begin with?
Probably when I was, I could have been as young as 4. I remember being outside. It was sort of dark. My dad was working. I think he was working on an addition to the house. And I think he had some help. But I remember looking up at the skies, and this was in near Washington, D.C., and I remember seeing all of these stars. Just, I couldn't count them all. There were so many. And that, I think, really triggered it right there. Seeing all the stars. And actually, it was sort of a dark area, even though it was pretty close to Washington, D.C. Now, of course, this would have been back in the early 1960s.
Right, right.
And I know it's grown somewhat, but still, Cabin John, the little community that I was around in my early childhood, it's still really not a typical suburb. It's interesting. I was there a few years ago, and still it kind of gets dark. I think the skies are not as dark as they were 60 years ago, but
Yeah.
it's still it's an interesting area. It's a really interesting little community. And so I was grateful to have lived there. And of course, that's what sparked my interest, was seeing all those stars in the
Interesting.
night sky.
Huh. So when did you get your first telescope, and what was it?
Oh boy. Technically my first telescope, if you can remember Cracker Jacks, little candied popcorn, they
Yeah.
give you a prize in every box.
Mm-hmm.
Well, in the sixth grade, my dad gave me his Cracker Jack prize, and it was a little tiny telescope, about 1 inch across, 1 inch long, and a quarter of an inch in diameter. That was my first telescope, and I remember going outside and looking at the moon. It looked bigger.
Huh. Really?
Yes, and of course, some people even collect those prizes. So
Oh yeah. Oh yeah.
you collect Cracker Jack prizes. There's a telescope, and I guess I got it around 1969 or 1970.
Okay. Well, how about a real telescope?
Real telescope, I gradually got bigger and bigger as I got older. I picked up a little bigger telescope. I bought it. It was a telescope microscope combination when I was 15.
Mm.
I think I did my first outreach with it. There was one or two neighbors who wanted to look through my telescope, and I let this one neighbor look through it at the moon, and she was impressed. Or maybe it was the moon or something, and she was impressed. So, and then I graduated. I remember getting a 2-inch telescope when I was about 20, and then looking at sunspots with it. And then, of course, I got a 4-inch telescope in the mid 1980s.
Okay.
And that's probably my first really nice one.
Okay. What do you currently use?
Believe it or not, I use a 12 centimeter refractor, which is about 4.7 inches, to study Jupiter a little bit. And then I use a couple of smaller telescopes with photometer to study pretty much all the other targets, Saturn, Jupiter, Mars, and even Uranus. I did use an 8-inch telescope. That's a little heavy for my mount. That's the problem. And of course, I've also had some health limitations. Of course, that's a little heavier of an instrument. So anyway, so it's basically sort of smaller telescopes I use.
Okay. Yeah, I know the older I get, the lighter I want the telescope to be.
Right. Questar is sort of my dream telescope.
Oh, there you go. Yeah. So you're the coordinator of the Remote Planet section. So tell me a little bit of the history of that section.
Okay. The section started, again, my memory's a little fuzzy, but somewhere in the 1950s. And an early coordinator of that section was Lenny Abbey, and he passed away about 5 years ago. But he was actually appointed when he was pretty young, maybe in his early 20s, and he wrote at least one report on the remote planets. It was back probably late 1950s, I'm thinking, and then that was passed on to somebody else. I don't know who that was. And then eventually Richard Hodgson took over the section, and that would have been during the 1980s.
Okay.
And then John Westfall appointed me coordinator of the remote planet section, I believe in November of 1990. And I said, wow, this is great. However, I knew better than to say, well, I'm going to go outside and try to make drawings. No. I said, no, I'm going to invest in a photometer and start making photoelectric brightness measurements. Now, as it turns out, Uranus does have some features people can image, but they need to use infrared light or red light and preferably a large aperture, 10 inches or more. And same goes with Neptune. And so anyway, and of course, I've been the coordinator ever since then. So that's almost 34 years ago is when I was appointed. Almost.
Long time.
Long time. That's right.
Yeah.
And I was fairly young when I was appointed. So,
of course, you're still young, right?
I'm 66. So,
okay.
If I live as long as my great grandmother, I'll be in my 90s.
Well, there you go. Something to strive for.
Yes.
So we're talking the planet Uranus and Neptune.
Yes.
Uranus is approaching that position now, I believe.
Yes, it'll be, I believe, around, it'll be in mid-November opposition, November 16th or 17th.
All right. So what do you want to tell us about the planet Uranus to start off?
Planet Uranus, it takes 84 years to make one trip around the sun. That means each of its seasons are 21 years long, roughly. 21 years. Now, of course, a season on the Earth is only 3 months long. And Uranus, right now, if you image it in near-infrared light, you'll see a big white area, which is the North Polar Hood.
Mm-hmm.
And it will be visible, I'm predicting, until the late 2030s, possibly even 2040. The North Pole of Uranus is going to be pointed nearly at the sun in about the year 2030. So we're going to have the polar hood around for a long time. Now, again, remember, it's only visible in near-infrared light. Don't try to look for it in, just normal visual light.
Okay.
Probably won't see it. Now, my area, though, has been measuring its brightness. In Uranus, the trend has been when it's at equinox. Now, when the sunlight's hitting the equator directly, Uranus is at its dimmest.
Okay.
And when the pole is pointed towards the sun, which is the solstice point, Uranus is brightest. And again, that's in visible light.
Yeah, and the interesting thing about Uranus is it's a tilt of its axis.
Yes, it's tilted on its side.
It's almost directly on its side. Yeah.
Yes, not quite. It's tilted. I mean, if you want to go with the mathematics, it's tilted by 97 degrees, which means it's the same thing as an 83-degree tilt, except it's rotating in the wrong way. So mathematicians like to say it's tilted by 97 degrees.
Okay. And that's why the North Polar Hood is something you see.
It's something you see now. Now, you see, the North Polar Hood was only a bright belt before 2016. And I discussed this in my report. But in 2016, that bright belt, which was around 45 degrees north, let's say, the area north of that all became bright. And by the fall of 2016, we now had a North Polar Hood, whereas in 2015, we only had a bright northern belt.
Okay.
And I suspect that happens with the South Polar Hood, but again, we didn't have as good images of Uranus back in the 1990s and 1980s when the South Polar area was facing us.
Right. Interesting.
Yes.
So that's the major activity going on in Uranus right now?
That's the major activity. And the second activity is, as I said before, it's dimmest when it's at equinox, and it's brightest when it's at solstice. That's the trend. And the difference in brightness is something on the order of 8 or 10%.
That's quite a bit.
And I suspect that increases as you go into red and infrared wavelengths.
Okay. Have you measured it in those?
A little bit.
Okay.
And that's actually Tony Malama and I wrote a paper on that. And actually several papers, one of which Tony wrote is in the journal Icarus.
Oh, okay.
The professional journal.
Okay. How many observers do you have that contribute to Uranus observations in the
That
system?
varies. I believe in the last report, which is typical, I had looks like 9 observers in the last report that I just submitted, the 23-24 report. I've
Okay.
had well over a dozen in some years, and others it's sank to 6 or so.
Now, what type of observations are you receiving?
I'm receiving a lot of images,
Okay.
and then Jim Fox, longtime
Hmm.
contributor of photoelectric brightness measurements. He's done a very good job of sending me several hundred brightness measurements. Unfortunately, he is moving, and so he will not be able to do that anymore.
Oh, okay. All right. But you get mostly images. Do you get any drawings at all?
I did get a few drawings, and a couple of them were pretty good. Rich Jekyll in Atlanta, or he was in Atlanta when he made the drawing. I don't know where he is now. I've kind of lost contact with him. Made a couple of good drawings.
Okay.
Showing sort of a bright area in the northern, I think it was the North Polar area. And I believe I reproduced that in my book on Uranus, Neptune, and Pluto.
Okay. So what size of telescopes are they using for the visual and images?
I would say 10 inches and up.
Okay.
Now, for photometry, you can use smaller apertures, but for drawings and images, I'd say 10 inches or 25 centimeters and up.
Okay. Interesting. So what about with Neptune? How is it different?
Neptune is different. First off, it takes 165 years for it to make one trip around the sun.
Mhm.
That means each season is 41 years long, roughly. It's going to be about a factor of 7 fainter, which means you really need a little bigger telescope to do images and also to make brightness measurements. Neptune, though, is interesting in that it has many more of the little bright spots across its disk, not just the polar area, but equatorial regions, temperate regions as well.
Okay. So where is Neptune right now in the sky?
Neptune is in the constellation of Pisces. And it's interesting because it's right around the vernal equinox.
Okay. So what type of observations do you receive for Neptune?
Pretty much the same thing. We
Okay.
receive images and then photoelectric photometry measurements.
Yeah, probably no drawings.
I don't think so. Occasionally we'll get a spectrum too.
Okay. Interesting. Cool. So is there anything going on Neptune that we should know about right now?
Yes. First off, it had several little bright spots. The James Webb Space Telescope imaged them.
Okay.
And secondly, it's a little brighter now than what it has been before about 1994. Around the mid-1990s, it brightened by about 10%. I'm not sure if that's due to seasonal effects or if it is due to something else that we don't know about. And this is why we need to continue measuring its brightness.
Right.
And it can be done with a CCD camera or with a single channel photometer.
Okay. That's interesting. So what do you see for the future of the Remote Planets section?
Well, what I see is I think the images are going to get better.
Mm-hmm.
I see people carrying out measurements further in the infrared. They made an SSP4 photometer. I have one. Unfortunately, it's not very sensitive, and so I need a really big telescope to do Neptune and Uranus photometry. Plus, those two planets are very faint in those wavelengths as well.
Okay.
My feeling is eventually they're going to come up with a CCD camera that will be able to image at wavelengths of, say, 1.5 2 or even 3 microns. They've got them out now. You need to plan to spend several $1,000s to get them, but I think that cost is going to come down.
Yeah, all the cost of that type of thing is coming down too.
So I think that what's going to happen in the future is people are going to image these planets further out into the infrared. And I think they're going to see some really interesting cloud formations and other types of heat even.
Okay. So are there books you would recommend for observing Uranus and Neptune?
Yes, my book, Uranus, Neptune, and Pluto, and How to Observe Them, published by Springer. It's still very good. Now, it was published in 2008, but it gives a lot of the foundation materials, talks about the eye, its limitations, and talks a little bit about Uranus, Neptune, both what the professional astronomers have done, what we know, as well as some projects that amateur astronomers can do.
Oh,
or small telescope operators. For example, photometry. I think people can even do photometry of some of the brighter moons. And this is needed because, as you know, Uranus's tilt is changing, and we're going to get to look at the northern hemispheres of these moons, which Voyager really didn't get to see.
True.
So I think that this is one area that people need to focus on. At least get the brightness measurements.
Right.
See if they match what they do for when the South Pole was facing us.
Okay. Are there any other books out there that you would recommend?
I cannot think of any at the moment. I'm pretty sure there's a Pluto book out. I remember seeing one that was pretty good. Of course, there's a classic book by Alexander that was written back in the mid-1960s, and he did an excellent job of researching his sources.
Okay.
But again, that's mostly for historical purposes. And of course, for Neptune, Patrick Moore also wrote a really good book on the history of how Neptune was discovered.
Right.
And I really would like people to look at that because there's really some misunderstanding. I think that one person, the astronomer Royal Airy was his name, really, he's painted as the bad person. I really don't think he is. He asked John Adams a question. John Adams did not answer. And I can't really fault the astronomer Royal for that. So again, very good book on the history of Neptune's discovery.
Okay, yeah, that's an interesting discovery. It really is.
Oh, it is. It's really
it
looks like.
It was actually mathematical, wasn't it?
It was mathematical.
Yeah.
Two different people used two different approaches and predicted where Neptune was, and their predictions were pretty close to each other. Mm-hmm. And then a third, really two others observed it. It was Gall, but his assistant also helped. And unfortunately, his assistant doesn't get too much credit, but you really needed two people to do it because one person was at the telescope, the other one was at a star map. And the person at the star map, he contributed too. That's my feeling.
That's true. That's true. Well, this is great, Richard. Is there anything else that you'd like to add about the remote planet section?
Yes. Pluto is also out there. I still like to consider it a remote planet. It's technically a dwarf planet now. It is well within reach of CCD cameras. And so some good CCD photometry of Pluto would be very welcome here. We did have one person do it probably 15 or 20 years ago. So we need to keep an eye on Pluto.
Okay. I did not know that Pluto was still a part of the remote planet section.
I considered it part of it. It was actually a planet until 2006. They changed it to a dwarf planet, but it's still...
Neil deGrasse Tyson,
Yeah, it's still bright enough. We really shouldn't let it just fall through the cracks. It's a special planet. We call it a dwarf.
Yep, I like
That's
it.
all.
Okay. Well, Richard, this is great. I really appreciate you coming on the podcast today.
Okay, you too, Tim. It was great great talking with you about it, and I wish you the best.
All right, you too, man.
Okay.
Well, that'll do it for this episode of the Observer's Notebook podcast. I again want to thank Richard Schumde for coming on and talking to us about the remote planet section. It was very interesting. Hey, get out there and observe Uranus and Neptune. Give it a try. We upload new episodes of the Observer's Notebook on the 1st and 15th of every month. You can subscribe to us on iTunes. If you do, please rate and review us. I really appreciate it. You can also listen to us on Apple Radio, iHeartRadio, SoundCloud, Spreaker, Google Play, Stitcher, Amazon Echo, Spotify, and this podcast is also available on our YouTube channel. You can help support the podcast by donating to it via Patreon, where you can give up to $35 a month, where you receive 1 year's membership to the ALPO and producer credits on the podcast. And with that, I want to thank the producers of this podcast, Steve Siedentop and Michael Moyer, for their continued generous support of the Observer's Notebook. The link for Patreon, as well as the link for the ALPO, is in the show notes. You can contact me via email at cometman@cometman.net or on Twitter at ObserversNBPod. And until next time, I hope you all have clear and steady skies. Thanks for listening.